The National Renewable Energy Laboratory reports that a modern solar plus storage system costs over $35,000. But in 2009, an independent energy consultant named David Mercer walked onto an off-grid farm in Ohio. He found a mechanical alternative that cost just $100. It was a crude thermodynamic engine built from scrap wood, single-pane glass, and cheap black paint. Yet Mercer's field report documented that this basic setup generated 2.3 kilowatts of continuous mechanical power. Without a single silicon solar cell, without a single toxic chemical battery. Shortly after Mercer documented the device, his report quietly vanished from public survey archives. This was not a conspiracy. It was a classic case of regulatory capture. Local utility monopolies have spent decades weaponizing building codes to restrict cheap, independent power. Standard solar panels must convert sunlight into electricity, store it in expensive batteries, and then convert it back into usable work. You lose energy at every single step. But this design bypassed the entire chemical process. It converted solar heat directly into mechanical gas expansion. It achieved a massive thermal concentration ratio of 110 to 1. How? By squeezing heat from an 8 by 12 foot collector box directly into a tiny 4-inch air duct. While expensive silicon panels degrade and lose up to 16% of their power on hot summer days, this system actually thrives on extreme heat. So how does a $100 wooden box turn raw heat into massive mechanical force? The secret lies in a basic law of physics that modern solar manufacturers hope you never discover. Every commercial solar panel comes with a hidden catch printed on the spec sheet. The manufacturer ratings rely on a laboratory baseline of exactly 25 degrees Celsius. That is a mild 77 degrees Fahrenheit. It is a temperature almost never seen on a real sun-baked roof. Once those dark silicon cells sit under direct summer sunlight, they turn into thermal traps. The surface temperature easily climbs to 65 degrees Celsius. At nearly 149 degrees Fahrenheit, the physics of the material begin to break down. The excited electrons inside the silicon start colliding randomly instead of flowing cleanly. For every single degree Celsius above that cool laboratory baseline, efficiency plummets. You lose exactly 0.4% of your power potential per degree. That 40-degree thermal spike translates to an instant 16% drop in electricity generation. Your expensive system is crippled at the exact moment the sun is shining brightest. To mask this inherent weakness, the industry surrounds the panels with fragile workarounds. They sell you chemical batteries and complex solid-state inverters that are designed to degrade. These components decay and fail every 5 to 10 years. What looks like a one-time $35,000 investment is actually a perpetual subscription. The Amish thermal loop completely reverses this thermodynamic penalty. Instead of fighting intense solar heat, this system treats high temperatures as raw kinetic pressure. It eliminates the delicate electrical middleman entirely. The design relies on a simple physical law, the rapid expansion of air sealed inside a closed loop. Think of it as a pneumatic heartbeat that pumps faster as the temperature rises. While extreme heat paralyzes modern silicon, it acts as a supercharger for this thermal loop. The hotter the afternoon, the faster the internal air expands. This expansion creates continuous, direct kinetic force without a single chemical battery. But how do you capture this high-velocity expanding air without precision industrial machinery? How do you build a rotor capable of turning raw, hot air into usable mechanical work using basic, everyday materials? The secret starts with a simple sheet of single-pane glass. This glass acts as a selective optical filter. High-energy, short-wave solar radiation passes straight through it. Once that light hits the matte black surface inside, it transforms into low-energy, long-wave infrared radiation. Because standard glass is completely opaque to these longer wavelengths, the heat becomes trapped inside the box. The air inside superheats, searching desperately for an escape. This is where the system forces a massive thermodynamic concentration. If you calculate the raw geometry, the math is staggering. The collector box measures 8 by 12 feet, giving you 96 square feet of surface area. That translates to exactly 13,824 square inches of solar harvesting space. The system channels all of this trapped air into a single 4-inch duct, which has a cross-sectional area of just 12.6 square inches. While this raw physical area ratio is over 1,000 to 1, fluid dynamics and boundary layer drag reduce the effective thermodynamic concentration ratio to a highly optimized 110 to 1. Squeezing the air through this extreme bottleneck forces its velocity to skyrocket. To convert this high-speed rushing air into mechanical power, you do not need expensive, high-tech commercial turbines. Instead, the system uses a custom-built radial vane rotor. This is essentially a lightweight paddle wheel welded from scrap steel plates. It spins smoothly inside a steel cylinder on basic, low-friction pillow block bearings. The rushing air slams into the metal vanes, converting thermal expansion directly into raw rotational force. But make no mistake, this is not a perpetual motion machine. It is strictly governed by the absolute laws of thermodynamics. Specifically, it is bound by the Carnot efficiency formula, 1 minus T sub C over T sub H. In this equation, T sub C represents the cold ambient temperature outside, and T sub H is the superheated air inside, both measured in Kelvin. Under this formula, the maximum theoretical efficiency of the engine depends entirely on the temperature gap between the inside and the outside of the box. If that temperature gap narrows, your mechanical power output drops. Unlike silicon solar panels, the energy density of air is incredibly low in overcast conditions, and those mechanical bearings require regular lubrication to keep spinning. But on a hot, sunny afternoon, this simple thermal loop produces incredible, reliable torque. Yet a static solar box only works at peak efficiency for a few hours a day when the sun is directly overhead. How did these off-grid builders keep this heavy system tracking the sun all day without a single electronic sensor, computer, or electric motor? The answer lies in a brilliant gravity-fed mechanical clockwork system that utility companies never wanted you to discover. But as these ultra-efficient, home-built thermal loops began popping up across the country, they caught the attention of the major utility monopolies. In 2011, a coalition of power corporations quietly petitioned federal regulators. They demanded that any independent energy system over a tiny threshold be classified as a controlled distributed generation facility. On paper, the excuse was public safety. And to be fair, real grid safety is a matter of life and death. When a home generator accidentally sends power backward into down lines, it creates a lethal hazard known as electrical backfeed. It can instantly electrocute utility line workers trying to repair the grid. To prevent this, regulators mandated industrial-grade automatic breakers, certified electronic inverters, and expensive safety audits. These mandatory commercial upgrades cost thousands of dollars. With a single stroke of a pen, a $100 self-reliant project was buried under a mountain of corporate bureaucracy. But this is where the safety rules crossed into pure corporate exploitation. Many of these thermal expansion loops were completely off-grid and entirely mechanical. They did not generate a single watt of electricity. Instead, they simply spun a wooden drive shaft to pump water, grind grain, or run workshop tools. It is physically impossible for a rotating wooden pulley to grind grain or run workshop tools. It is physically impossible for a rotating wooden pulley to send an electrical backfeed surge into a high-voltage copper line. Yet the weaponized safety codes treated a mechanical drive belt exactly like a live copper wire. The genuine need to protect line workers was twisted into a legal fortress. It was designed to price low-cost, off-grid competition out of existence. But these independent builders did not waste time fighting the legal system. They bypassed it entirely by keeping their designs completely mechanical and off the grid. And to make their systems truly unstoppable, they had to solve the ultimate solar challenge. They had to find a way to track the sun across the sky without using a single wire, sensor, or computer. To build this high-performance thermal trap, you start with a simple wooden frame. Construct a sealed box using rough pine boards and line the back with scrap mineral wool insulation. To coat your metal absorber plate, skip the overpriced industrial coatings. Instead, blend standard matte black heat-resistant paint with fine carbon black powder. This simple mixture alters the surface texture to capture 95% of all incoming sunlight. You get a 0.95 solar absorptivity rating for pennies on the dollar. Next, seal the front of your 8x12-foot box with a single sheet of standard window glass. Do not use double pane glass. While double pane glass seems like a smart choice, it actually acts as a barrier that reflects away vital solar energy. A single pane allows high-energy shortwave light to pass straight through, but once those rays strike the black metal plate, they transform into long-wave heat. Because glass is completely opaque to this longer wavelength, the heat is permanently locked inside. This simple thermodynamic trap achieves a staggering 110-to-1 thermal ratio. This ratio is the core secret that drives the entire system. It creates a massive 110-degree temperature differential between the outside air and the interior core. On a standard 84-degree day, the air inside your collector spikes to a blistering 194 degrees. This intense heat expansion forces air to rush through the 4-inch pipes at high velocity. As the pressure inside this sealed loop builds, you must install a mechanical pressure relief valve to keep the frame from bursting. This superheated, pressurized stream is now ready to drive your custom radial vane rotor. To keep this thermal engine running at maximum power all year, you do not need expensive motorized trackers. Just mount the collector on a basic manual hinge and tilt it 4 times a year to track the seasonal path of the sun. Set it to 25 degrees to catch the high summer rays. Adjust it to 45 degrees during the spring and autumn equinoxes, then tilt it up to 65 degrees to capture the low winter sun. But even the most efficient solar loop is useless once the sun goes down. To achieve true off-grid independence, you have to solve the ultimate challenge of storing this energy overnight. And the solution does not require a $10,000 lithium battery bank that will degrade and fail. Instead, these builders used a simple, heavily insulated steel drum. To do this, you do not need a $10,000 lithium battery bank that will degrade, fail, and eventually end up in a landfill. Instead, you can build a high-capacity thermal battery using a simple, heavily insulated steel drum. Fill this drum with ordinary river gravel. Make sure each stone is roughly 2 to 5 centimeters in diameter to allow optimal airflow. During the peak hours of the day, the excess superheated air from your collector is diverted directly through this stone bed. The dense gravel acts as a massive thermal sponge, absorbing and holding the heat for hours. When the sun sets and the air cools, a simple mechanical check valve automatically redirects the loop. Cold air is drawn back through the hot stones, instantly warming it to keep your thermal engine spinning long into the night. But there is one critical safety rule you must follow when building this thermal battery. The river rocks must be completely dry before you seal them inside the drum. Any trapped moisture will instantly flash into high-pressure steam under extreme temperatures. This can violently rupture your storage tank. By keeping this entire storage and engine system completely mechanical, you unlock a massive legal loophole. You do not register your setup as an electrical generator. Instead, you classify it as agricultural mechanical equipment, because a purely mechanical belt driving a water pump or a workshop fan completely bypasses local utility grid codes and safety regulations. You are not connecting to their wires, so they have no legal authority to shut you down. It is the ultimate way to reclaim your independence by working with basic physics instead of fighting corporate lawyers. But mastering the power of thermal expansion can do far more than just spin mechanical pulleys. It also unlocks the key to your most critical survival need: pure, clean water. By applying these exact same thermodynamic principles, you can build a highly efficient water distiller from basic scrap metal. It purifies water continuously without commercial filters, chemical treatments, or a single watt of electricity. Click here to see exactly how to build it and secure your water supply forever.